Good afternoon, everyone. My name is Vikash.
And my name is Swapnil.
So we had the enlightened talk since yesterday morning, and we have listened three professors from different IITs. So we will talk about the importance of quality control in LC3. So in the presentation, we will focus on the key points we should keep in mind while making the LC3 blend. So we will continue from calcination to the grinding protocols, preparation of LC3 blend, and different colors of LC3 and the admixture in LC3.
So the calcination of clay is generally done with the temperature range of 700 to 850 degrees Celsius. But in our lab, we generally calcine the clay at 800 degrees Celsius, and we get good results in terms of lime reactivity and compressive strength of LC3. But also in some of the clays, we calcined at 800 degrees Celsius, but we didn't got the good results. So we checked for the quality of calcination, and we found that our clay was under calcined. So we increased the temperature up to 900 and again calcined, and we found the good results.
So the temperature does not remain same always. We got more than 10 samples every month, and we characterize and we do check for the calcination for making the LC3. So it depends on the many things like mineral composition, some minor phases inside the mineral, and the crystallinity of the clay. So this is the process that we follow. We put the ceramic pot inside the Mohel furnace. This is the static calcination. We take care of the filling depth of the pot. So we keep the sizes of the feed around 10 to 20 in the lab protocol, and the filling depth around 15 to 20 mm. So the residence time, as we discussed yesterday, we take the residence time of 2 hours. It's little more, but we should it kept more because for calcination should be perfect.
So after the calcination, our next step is grinding and homogenizing the material in our lab. So we use lab ball mill, in which we have set some protocol like we use 1:5 ratio of sample to grinding media, and we try to finely grind all the material below 90 micron. As the clinker is hardest among all the other components, so we grind it more as compared to the other component of LC3.
So this term looks very simple and easy, but it is very difficult. When we go in industry, then it is very difficult task to do. So in the lab practice, we use the ball mill, but we do the separate grinding. We do not do the inter grinding. There is in the inter grinding there is a relative difference in the grindability, just because we are adding clinker, limestone, and harder and softer material both. So there is a relative grindability difference. So we use the separate grinding, and it enhances the particle size distribution in the whole LC3 blend.
So what is the composition of LC3? As we all know that it is 50% clinker, 30% calcined clay, and 15% limestone, 5% gypsum. But it is not always the same. We change the composition according to the requirement and the characteristic of the material.
So this is not same always. If somebody want like a spicy biryani, somebody want a normal biryani. So somebody asked the question yesterday. So is it always same? So it is not always same. We need to do the sulfate optimization. So the blend obviously changes. And somebody wants normal biryani, so they can make the LCD 30. So it will change. You can make the LCD 50. It will change. It will change all the compositions.
So after optimizing the content of the LC3, we mix them in the mixture, and we all together we have mix in our 3D turbo mixture, in which we run this for 3 hours at variable speed.
So we use the 3D turbo mixture for blending of all the ingredient in the lab. Sometimes we do not have the 3D turbo mixture to blend at the site or in other institutes. So there what to do for doing the casting to check the strength of the blend. We do prefer and we did it in the last plant visit. We made the LC2 slurry. First we took the limestone and the calcined clay, and we mixed together with the 70% of the water which is required to hold casting. And thereafter we mixed together the LC2 slurry, and we made the slurry of the Lc2, then we introduce the OPC which is required, that is 50% of the Lc3. Then after we prepared the mortar mix and cast the cube, and we got the equal strength results as we do earlier. Like we mix the Lc3 and the sand together. So there is not much difference.
So here you can see the different Lc3 blend we made in our lab, and we've seen that all are of different color because of the different clay color of calcined clay. So color is different, but the strength is same.
So I would say please don't judge the cement by its color. The color may be different just because of clay. So next is the fineness test. So once we grind the material in the ball mill, so the grinding protocols are in the lab are different. So we need always to check the particle size. We do prefer the particle size analyzer to check the distribution of the particle and the good packing of the particle. So we check the particle size distribution, and the sonication is must. Sonication helps to to disperse the particle. We agitate the particles inside the isopropanol. But we have observed from the in the lab that 90% particles are falling around the 45 to 55, and we are getting this length. This is very high. It is concerned, but in actual practice in the plant production, this is not very high. It is around 400. So need not to worry about it. The next is the line reactivity. This is the first strength check. This is the green signal which tells us about how the material is reactive. That is calcined clay is how it is reactive. So first we calculate the specific gravity, then we find the optimum below. I think most of us have seen yesterday. Then we cast the line reactivity cube. So according to the IS code 1727, we perform this test. So this is the whole procedures in short, but in code this is very big detail given in the code. So after the 8 days of curing at a certain degree of temperature and humidity, we got the strength. The strength should not be minimum, not less than 8 megapascal that is proposed for limestone calcined clay.
So normal consistency and setting time is important parameter for our Lc3, and this normal consistency is performed according to the Indian Standard Code 4031. Generally, normal consistency of Lc3 is higher as compared to the OPC. Also, we have learned that the grinding of the material is also important for normal consistency. So if the Lc3 is finely ground and we get 2 to 3% higher NC as compared to the OPC. But if the Lc3 is not properly ground, so we may get 4 to 5% increase in the NC of Lc3 as compared to OPC.
So finding the NC, the protocol are same as we use in case of the OPC and PPC. So the method of finding the NC is same and same for the setting time. So as he said, the fineness matters a lot in case of finding the NC. So we need to focus on the grinding of the material. So this is the Vikash apparatus we use to find the NC, and this is the mixing protocol we use. And here we have some data from the plant. This is the OPC and this is the Lc3 from the plant, and we can see there is not much difference in the normal consistency. But previously I have some data. I had seen the NC was more than in comparison to OPC. It was 4 to 5% more. But in the plant production of Lc3, I can see that there is not much difference, and good results are there. For the setting time, they have improved the setting time also. But I have never seen this setting time in the lab, the grinding. It is good thing for us. Next is the admixture in Lc3. So since the clay is very, very fine and surface area of the clay is more cohesive in nature, when we introduce the water for making the paste, it start agglomerating and we need to disperse the particle of the clay in the system. So we need some admixture. So we use the PCE based admixture to have the disperse. It helps us to disperse the particle, and it also improves the strength. So this is the result with without admixture and with admixture of Lc3. So you can see the results. This is the picture I have taken from Professor Susan Vishnoi's PPT. So you can see the strength increasement in here. Thank you.